Okay, here's an interesting question, very much a HL applications style question. And got a little toolbox here. This is actually given in the formula book, but it looks quite scary. But we are going to be using both this formula here and also these formulas here. They look quite complex, but we'll apply them to the question below. Right, so let's get into it. I'm just going to read through. So there's this drinks manufacturer. There's two sizes of bottles, small and large, handily notated as S and L. The distributions are independent. Well, that means we can combine these distributions, and they are normally distributed. Okay, and it gives you that the mean volume for each. And now this next number is the variance, the variability of the volumes. Okay, so let's have a little look at what the question actually asks us. So for part A, a bottle of each size is selected at random. Okay, so we're going to choose one S and one L. Find the probability that a large bottle contains less than 2 times the amount in the smaller bottle. So again, there's a lot of information there, but we're going to just try and write it down as an inequality. So we've got a large bottle. This is part A here. We've got a small bottle, but it says 2 times the amount in the small bottle. So that's basically take a small bottle and times the contents by 2s. And we want the probability the large bottle contains less. So this is what we're looking for, L less than 2s. But then we're going to do a small bit of rearranging, L minus 2s less than 0. And that's the key for these questions. We're actually going to combine some distributions together, and we're going to see what happens from there. So what we need is to get our thinking heads on. If we combine normal distributions, because L is normally distributed, S is normally distributed, so actually if we combine these together, then these will also be a normal distribution. So what we need is the mean and the variance of this normal distribution. So we need the mean of this distribution, and we need the variance of this distribution. And this is where the formulas kick in. All right, so the formulas back here just tells us, look, that E of AX plus B, we just unpack, and var of AX plus B, we also follow this rule. So let's have a little look then. So this is E of L minus E of 2S. Let me just move the var down a little bit. So this is E of L minus 2 times E of S. Okay, so let's go back and find what is E of L. Well, E of L is the mean bottle volume, which is 575. So just transfer that in place. Minus 2 times by E of S. And E of S is the mean of the small bottle, which is 280. And then we just flick to our calculator, and we have 575 minus 2 times 280. I think I could have done this in my head, but I'll just check, and that's 15. Okay, so the new mean is 15, and that's 15 milliliters. Now the variance is a little bit trickier, so we unpack variance. We go back to the big picture here. So this is variance of the large bottle, and then we need the variance of 2s, and this is variance of L, stays the same, and this is actually 2 squared the variance of S. And if we look back up here, the formula we're looking at actually is this one here. Okay, And so that's pretty important, but we're also looking at this little bit here. And notice when we unpack this bottom bit, all of the variances are added together. So this seems a bit counterintuitive, but when we subtract distributions, the variability actually doesn't reduce, the variability actually increases. So this is the formula we need to answer to get the variance of the new distribution. So let's just go and transfer the numbers down now. The variance of L, well, that's the 16 here, and the variance of S was 4. So transfer those numbers down. That's 16 plus 2 squared times 4. Okay, then that 16 plus 16 is 32. So these are the new mean and variances for the distribution we want. So if we just go back, add an extra page here, then what we have is L minus 2S, which is what we're interested in, follows a normal distribution because we're combining other normal distributions, and the mean of this is 15, and the variance of this we said was 32. And now we can actually go ahead and draw a nice little normal distribution for this situation. There we have it. So this mean is 15, and the standard deviation is the square root of 32, because 32 is the variance. And finally we want part A. The question was, what's the probability of L minus 2S from before, less than 0? So we put 0 on here, and we're actually looking at this area here. So let's go. So let's finish off this question now. We are looking for a particular probability here, as given by the diagram. We're looking for the shaded area here, and we're on a normal distribution. So we are going to look at norm CDF from the calculator. So let's go to our calculator now. Menu, probability, distributions, norm CDF, and the lower bound will keep as -9 times 10 to the 999. Upper bound is 0. Mean is 15. Standard deviation. Now we can just type in root 32. We don't have to work it out and type it in as a decimal. The calculator will sort it out, and look at that, 0.004005, maybe to 3 sig figs though. And let's just get the iPad out again. So the answer here is 0.00401 to 3 sig fig. And we'll have a look at the second question now. So part B now. The last question we had to flick backwards and forwards from the question to the answer. So here I'm going to just put a little bit of guidance. E of L and var of L, and E of S and var of S. So we just transfer the data from the question into the right place. So E of L and var of L. So E of L is 575. var of L is 16, and E of S and var of S. So that's 280 and 4. So this should help us with the second part for part B. Alright then, let's have a look at B then. So B, 1 large and 2 small bottles. So these are 2 separate bottles, S1 plus S2. So it's not taking 1 bottle and timesing it by 2. It's doing 2 separate small bottles. So the distribution here will be slightly different to part A, and you'll get to see just how different it is. Find the probability that the large bottle contains less than the total amount in the 2 small bottles. So we just want to replace the symbol here with an inequality. So this is what we're after, and we are going to rearrange this as we did before. L minus S1 plus S2 is less than 0. So we really want to find the expected value of L minus S1 plus S2. I want the variance of L minus S1 plus S2. And using our formula from before, it's going to be E of L1 minus E of S1 plus S2. And then we just transfer down from above. E of L is 575. And down here it's going to be E of S1 plus E of S2. Again, you don't really need all this notation, but I think it helps. And that is actually the same mean as before, but it's actually the variance that changes. So this is var of L1, of L, and then plus var of S1 plus S2. So in fact, it's not 2 squared the variance, it's just the variance of L, which is 16, plus the variances of S1 and S2 added together. So this is 4 plus 4 here, so this is 24 in fact. Right, so let's do one final picture. So I've got the picture already drawn there, and the variance was 24, so the standard deviation equals root 24. We've got the same mean as before, 0 is here, and we're looking for the same area on the particular graph. So again, let's go to our calculator, and we get our calculator up, and we do menu, probability, distributions, norm CDF, lower bound as before, upper bound 0, mean 15, and standard deviation is this time root 24. And OK, and this time it looks like, oh, let me just check if we've got that right one there. It looks like it's already rounded it off, but let me just try again. Menu, probability, distribution, norm CDF, upper 0, mean 15, standard deviation is root 24, close the bracket, press OK, there we go. That's a slightly different answer there. Okay, so good job I checked it. So we've got 0.001 and it's 0.99, and my grade 7 class are coming in. So to 3 sig fig, 0.00110, a little bit technical at the end there. So the two answers are slightly different, and that's largely because you have a different standard deviation for each distribution.